Now let's look at another example over here. So we have our second differential equation over here. We have y prime of x is equal to y cubed. So what it means is that we have f of y over here is y cubed. So let's try to find y star, the equilibrium. That means we set f of y to 0. So we have y cubed is equal to 0, then the only solution we have is 0. Okay. So that's how we find an equilibrium. And then we take the derivative of f of y, and then we have 3y squared. Derivative with respect to y over here. And just to be careful, we have derivatives over here of two types. This one over here, derivative, is with respect to x. And that's another reason sometimes we use y dot of x, and that means dy dx, to avoid confusion. Now, let's look at what's going to be a derivative of this function at equilibrium. And then we have 0. So if it's 0, then it's not positive nor negative. So our test, so-called the derivative test, fails. So we say test fails. And we cannot really determine the stability of this 0 over here using the derivative test. But on the other hand, if we use geometric method, it works. Let's look at what's going to happen if we draw the diagram of this function. So this is capital F of y, and it's y cubed, right? And we have something like this. And again, this intersection with y-axis means you have equilibrium. This is equilibrium. And then we say, look, the value of the derivative over here is negative, and here derivative is positive. If it's negative, that means values of y are decreasing. And over here, positive, that means value of y is positive. So if you look at this point over here, it is unstable. So by looking at this method over here, we say y star equal to 0 is unstable. Unstable means if you look at nearby solutions, the solutions are not only not converging to 0, but they are leaving 0. And we are not going to be very precise about the definition of unstable and stable. Just use our common sense. Stable means your equilibrium is not going to do much damage to nearby values. If values are nearby, they're going to stay nearby or converging to this 0. But unstable, that means your equilibrium is going to push other values away. Sometimes we say it's a repeller. So this one over here is a repeller. Is a repeller. Alright, that's the end of this simple example. In this example, we are able to find the equilibrium, but we are not able to determine its stability using the derivative method. But we are still able to determine the stability using geometric method and get a sense what kind of dynamics we have.